So for today, our final presentation is on the BI tool for data visualization. Our group set number is 4, and we have Alicia as a Scrum Master, Agam as product owner, Simi as team lead, Ashwata as designer, Jasdeep as designer, and Raghav as our developer. Next slide, please. So for the introduction, the objective of this project is to create a flexible business intelligence tool tailored for a data warehouse with an emphasis on visualizing data with algorithmic systems. The tool is designed to collect and analyze data from sources such as Yahoo Finance. Users have the option to personalize their dashboards by incorporating widgets and charts based on real-time and past analysis. So going into our UP phases, we have inception, elaboration, construction, and transition. So starting off with inception, it takes place as soon as we initiate the project by outlining the objectives. At this stage, the team engaged in discussing to determine the project for the semester, and we started creating the Gantt and PERT charts, as well as the use case specifications for customizing the trading dashboard. For elaboration, it's the phase that's dedicated to project planning. So during this stage, the team initiated development design elements for the project. So the efforts of the team are best shown in milestone 1. This incorporates the use case diagram, activity, and including some design patterns such as creator, information expert, low coupling, and MVC. We also have included a partial architectural structure and class diagram during this time. The team also began building the code and presented the first version during our milestone 1 presentation. So for construction now, it's the phase where the implementation of the remaining elements is introduced. So we've updated our class diagram at this point, domain model, activity, and use case. This also includes a sequence diagram for stock prediction apps and the design patterns for MVC, creator designs, and creator have also been updated. For the documents, we included the SSR, the glossary, vision, and test work with results. Along with the diagrams and documentations, we've also updated and completed charts and graphs in our code. And then we're in the transition stage right now. So this is at the end of the semester when we're beginning to wrap up everything. So in this stage, our focus shifts to preparing for the presentation and set to deploy the final prototype. Prior to this phase, we updated the prototype code and documentation with the feedback we were given in a previous milestone.
Right. So for drawbacks, over the course of this project, our team actually worked together pretty well. There were little to no issues. Only issue was the lack of communication and commitment from members for scheduled meetings. But the issue got resolved pretty quickly, and ever since it's been pretty smooth. So on to the next slide.
The use case diagram describes the high-level functions and scope of BI2 trading system. This diagram identifies the interactions between the system and its actors. The actors are analyst and system admin. The external system is Yahoo Finance. The use cases involved with the primary actor analyst are customizing the dashboard, performing the data analysis, and visualizing the data. Next slide, please.
So for the class diagram here, the class diagram usually models the objects and the relationships between the objects, such as the human interacts with the Streamlit app, and which in turn interacts with the report and the prediction tool. And yeah, as is seen here, there's a one-to-many relationship between the Streamlit app and the report, and there's a one-to-one with the prediction. And yeah, on to the next slide. And so for the domain model, This more so shows the relationships between the different objects here. So the human interacts with the Streamlit app, and the Streamlit app shows the report, and it also generates the prediction as well. Yeah. On to the next slide.
So now we're going to be talking about the system sequence diagram. So during inception, this diagram was created to know the functionality of the code. It's considered a high-level system sequence diagram where the system is a BI tool. The user requests data according to the year. From there, the BI tool will check the data availability in the data warehouse. From there, the data warehouse will then send back either the data or an error. Next slide.
So here we have our activity diagram. Activity diagram is used to show how the system is actually working and how the activities and the operations flow. So in the starting, we have the activity or the operation of selecting stock, and then a decision statement comes, and based on whether the stock is selected or not, it branches into two sections. And if stock is not selected, it displays the message that please select stock, and this branch ends. And if the stock is selected, the next activity is select years, and then the raw data is plotted, and forecast is displayed, and then we display the comments and then display results, and then this ends.
Design patterns. The BI tool, it has been built to implement all the 9 GRASS patterns as well as GOF design principles. So here we will be having controller design pattern, creator design pattern, adapter, singleton, and abstract factory are from particularly GOF. We will also be showing that how there is low coupling and high cohesion in our design patterns, and pure fabrication, protected variation, and interaction. Next slide, please. So the first is the controller. So we have made our app according to the MVC pattern, in which the modelet is basically performing all the analysis tasks, that is, it is fetching the market data and performing the analysis. Further, we are having the view, which is our Streamlit app, and it is a library which we have installed. Controller, it is basically a root that acts in between model and view. Next slide. So here we are having 3 design patterns: creator, adapter, and singleton. Creator is a design pattern that is used when a class B, it aggregates a class A. So for here, Streamlit app, it is actually aggregating the Prophet app. It would be creating that this class when the user would be asking for the years of prediction. Further, we would be seeing that the adapter class, it is a class that would be transforming the data, taking it from the Streamlit app, and then changing the date as DS and the closing value as Y. And the Prophet, it accepts the data in this format only. The singleton, it is basically present over here because the Prophet could be making only single instance of its class, and this Prophet instance in our code, it is named as M. Next slide, please.
So next up, we have the low coupling and high cohesion. So this is another design principle which focuses on reducing dependencies between components, which is very important since if the system is has a low coupling, it means that they're not dependent on each other, which means that if one of the system fails, then the others can handle their own part and the entire system doesn't crash. And whereas high cohesion is design principle that focuses on the structure of components, which means that each class should have a single well-defined responsibilities. This ensures that there's no overlapping, and every module and class has a defined scope of the things that it wants to do. And our code, we believe, is we've tried best to add these components in there. And you can also see in figure 8 that there is high cohesion and low coupling, as the responsibilities are divided between Streamlit app and the Prophet. And it shows that if there's any problem in functioning of either one of them, the other one would continue functioning. And we will also try to improve this in the future. Next up, we have the design patterns that have not been explicitly stated, but it can be found in the previously mentioned design patterns, such as pure fabrication. This means that we are sharing the set of responsibilities by creating a new class, and with this also maintains low coupling and high cohesion. Here we can see that the adapter class we have created, it shares the responsibilities, and responsibilities are being provided to this class. Up next, we have the protected variation. It could be shown through the Prophet singleton class. So protected variation basically means that it's encapsulated. So any changes in the higher level would not affect the contents of this class, and it would remain secured. And it safeguards the app and variations in the model's internal details.
Further, we are having generally the adapter class, which is a GOF pattern. And if a pattern, it is particularly GOF, it might be encapsulating the graphs patterns in it. So for the adapter class, it could also show us the indirection and pure fabrication. The adapter, it is generally indirecting the things. It is acting as an intermediate, uh, not having the direct coupling in between the Streamlit app and the Prophet class. So that's why the adapter, it is basically acting as an indirection design pattern. Next slide, please.
For the charts that we are creating and the graphs that we are using graph objects, which is a low-level interface to add figures, traces, and layouts in our program. It acts like a abstract factory to create objects like scatter graph and candlestick chart. We do not do everything from scratch here. We just import the graph object module from the Plotly library, and then we send the specific data that we want according to that data specified, we get the chart that we want. So that's
Right.
all.
So now for the software requirement specification. This document was created previously and it's been updated for now with the version 2. So if you want to press the link, you can scroll through that. And its purpose for this specific, or the role for it, is to outline the requirements for ourselves as in the team, as well as stakeholders and other clients. So just scroll through the entire document. Next slide.
For the vision document, the objective specific capabilities required by the stakeholders, namely including the system admin and the stock analysts. We can just have a look at the vision document. Moving on to glossary, the business intelligence tools glossary serve as a reference guide detailing the project specific terms and concepts. It ensures that the project documentation is written in a common language so that it is easy for everyone to use it. The link for the glossary document is given. So we have all our terms that we included in our project and the acronyms mentioned in the glossary document.
Further, there is testing. So the stock prediction app was a complex application in which we forecast the data for Apple, Google, MSFT, and Tesla. It is based on the historical data that we actually fetched from the Yahoo Finance. And for the prediction, we generally use the profit model, which is a non-linear model. And so it is very important to test the application for its user interface and reliability and correctness. If you could scroll down through the document. Yeah. So here it could be seen, like if you can scroll down. Yeah. So in the testing plan, it could be seen that first we did the unit testing. In the unit testing, all the functions were tested, like the load data and plotting the raw data. Then in the integration testing, we generally selected a data set and then checked that whether the data was loading properly, plotting, and further forecasting was done. In the performance testing, the time was recorded in which the app it actually responds, and like is the response affected when the maximum number of years were selected. In the user interface testing, it was tested that um, how much interactive it is with the user, like whether the subheadings they are consistent or not. In the regression testing, when we added a new feature candlestick and the design patterns, it was checked that the overall functionality is not hampered. And further, in the testing design patterns, we checked out that um, the design patterns are working correctly or not. So you can just scroll down. So here we can see that each and everything is getting tested, and we generally use the input data set, like we use the test data and not the data that was coming.
So to conclude the presentation, I would like to say that over the semester, our team worked to conceptualize, design, and construct a prototype for a business intelligence tool. And as a outcome of this project, we have learned skillful application of design patterns to write more neat version of our code. And working as a team, we also learned how to collaboratively work on a software project, not just to design and create it, but also how to document it for the users. And now we'll be going over to implementation. So I will share my screen now. Yes. So starting with Alicia and Smith, we'll start with Yahoo Finance.
So for our implementation, as you can see on line 1 of our code, we are using the Streamlit library to integrate the app, and we use Streamlit as it is a promising open source Python library which helps the developers to create the user interfaces efficiently. On line 4 of our code, we use Yahoo Finance Python library to download the market data from Yahoo Finance. Yahoo Finance offers a variety of data, market data from stocks and cryptocurrencies. It also provides news reports with various insights into the different markets from around the world. And all of this is accessible through the Yahoo Finance Python library. It's the most popular way to access the Yahoo data, and the API is open source and easy and free to use. That is why we chose to use it. On line 10 of our code, the start date is set to January 1st, 2015, and the title for our application is Stock Prediction App. As you can see on our Stock Prediction app, we can select the data set for prediction. So right now we have 4 options available: Apple, Google, Microsoft, and Tesla. So the user can choose any of these. In the future, we decide to expand our data set to more data set. And with the slider, the user can select the number of years to predict the stock data from 1 to 4. Next, Ashmita will explain the code. Alicia will explain the code. Sorry.
Okay, so on line 23, the object ticker loads the data for the selected stock, and it downloads the data from Yahoo Finance and prints the data. So while the data is loading, the app actually displays loading data up on the right-hand side. And once the raw data is ready, the app displays loading data. So now Raghav will print the data. We have about 7 columns and several rows to display. And so in our raw data, we used the columns date, open, high, low, close, adjusted close, and volume. And we also use the open and close price from the data to plot the scattered graph, candlestick chart using the Plotty library. And then next up is Raghav and Jasdeep.
Yes. Starting with the scalar graph, as mentioned in our presentation, we are using the graph object library, which is a low-level interface to figures and traces. So it acts as an abstract factory. We just send them the type of graph that we want it to create, along with the data, such as date and opening data. Then in the end, we get the graph, and we get the graph we want, and then we plot that graph. Here you can see we are using the stock opening and as well as the closing data. When this graph also allows the user to interact with the stock, so it makes our business tool more interactive as well as user friendly. So now Jasdeep will go over the candlestick chart.
All right. For the candlestick chart, it's also data from the Plotly as well, and so we give it the data for the date, and it also displays a open, closed, high, and low data as well. And it also has a rangefinder, like an interactive tool as well. So if you scroll along, it shows you every specific date and the status of the data as well, if it's open or if it's closed, if it's high, if it's low. As you can see there, everything's displayed here as well. And yeah, so for line 59 to 60, it just plots the scatter graph and the candlestick graph as well on the actual Streamlit app. And yeah, on to the forecast with the profit.
Yeah, so in our program, the forecasting is actually done through an algorithm Prophet. It is a Facebook, it is provided by Facebook, and it is an open source algorithm. In the 5th line, we can see that we are importing the Prophet, and it is a procedure for forecasting time series data model based on an additive model, which breaks down the forecast to yearly, weekly, and even hourly trends. And Raghav can show you that is already shown you, and it can show you that every in the chart, if you can show you that we can go down to even the hours, like in the plots if we zoom in, and also Facebook implements an additive regression model, which means that based on change in one variable, we predict the changes in other. Here we can see that the date, based on changes in the date, and the stock is the dependent variable, and it's changed, and that's how we forecast. Here, the data it all happens on the data set, and the data set is provided by we have picked up the Yahoo Finance data set. And the one good thing about this profit model is it automatically picks up change points in the data set, and it also has a holiday list, so that all the holidays during which stock is not to be predicted, they are excluded in the forecast. And we use this model because it is accurate and very fast, and also it's automatic, so you don't really have to do any coding. And again, it's as we talked before, it uses design patterns such as uh, protective variation, because it is encapsulated, and any changes in this code would not affect. And you can also make changes to the domain, which we can do in the future. Right now we have. Now Agam will be explaining it more.
So here particularly we are having a class adapter. So this is showing that how the data is transformed. So the data that is coming from the ticker, we selected the data set. Can you scroll down above, like Raghav? And in the app, we can be seeing that in the app, we can be seeing that if we select any data set, like we selected AAPL, and we did the years of prediction as 2. So we would be able to see that it will be showing us the data for 2 years. Now in the code, we can be seeing that there is basically an adapter class which is transforming the data. The data set, it basically needs here to be having the data column as DS, that is date timestamp, and the closing should be like Y. If the data is not transformed, it would not be fitting in the model. We have used the adapter class, which also shows us the adapter design pattern, why it is particularly a numeric value. Further, we would be also seeing that here there is the use of singleton design pattern, because only one instance of the prophet can be formed. The prophet constructor will be fitting the historical data set over here. For example, here we have selected GOOG. So that is particularly fit over in this model. Then this make future data frame, it is basically a method which would be extending our historical data to the number of years which the user has been selecting. So here the user has particularly selected 2 years. So it will be extending it over to 2 years, but it could not be deleting the data for the historical years. Like here we can be seeing that it is showing the data for 2016. It is showing it for 2004 as well. So that data is not basically get hampered. Further, we can be seeing that the forecast in which we have used the predict method in the predict future. So here it will be adding the y hat value. This is particularly a predicted value that it would be giving using the method predict. And further, we would be seeing that in our forecast data, if you can go above, Raghav. Yeah, here we can be seeing that this data set, like if we go to the date, so we can see that this date timestamp, that it is giving us the last years, because we have selected the tail thing. So it is giving us the last year's data, that is 2000, the 2 years later's data. Further, we can be plotting it using the Plotly. And at the end, we can see that there is forecast. Forecast can be trend weekly and yearly. Here we have generally excluded the holidays present, and that could be shown in the figures. It is just a simple method, that is plot components, and that will be plotting the 3 components consecutively. Thank you.
So that's all for our implementation. This basically shows how we have used Yahoo Finance and Profit in conjunction with each other to create a stock prediction app which takes the real-time data from Yahoo Finance and then using the time series forecasting for linear regression shows the forecast for the number of years that we want. I've also uploaded this on GitHub so that I can host this on this URL. So if you guys want to check the app and play around with it or even suggest some changes, I'll be more than happy with that. So here is the link for that. So that's all for our presentation. Thank you.